Hey guys, welcome to Bar Z. My name's Stan, and today I've had a project sitting on my shelf for an awfully long time. This is a 20 millimeter linear bearing. Length is roughly 36 inches long. So, and the linear bearings, they're capable of linear motion, oddly enough. And we use these a lot with reciprocating spray arms and things like that. So I know how critical the alignment is on these things. And what we're going to do with it, we're going to attempt to make a taper attachment for the lathe. Now what I've done is I've kind of gotten started. Here's one piece here. If you look at this profile here, you'll see it's been milled out, plus a little relief groove to take care of that outside corner on the lathe. And then we've got a little flat bar that just bolts on there, and that serves as a clamp. That's what's going to clamp it to the bed. And here's the other side. This hasn't been milled out yet, but same thing. We've got our milled spot in there, and we've got a little relief groove. That's just a slitting saw. You put the part in at 45 and run a slitting saw through there. And that's about a 60 thousandths depth, just to create that that relief in the corner. Now, then what we're going to use to hold the bar are these clamps that I made. I went ahead and finished these, and I put a quick heat blue on them at about 475. You get that color about 475 degrees. Now this is going to serve as a pivot and a clamp. These are going to go on the ends of the rod here. Let me capture that bearing. So it's going to go like that right there. And then we've got another one here for the other end. So that's kind of what you got there at each end. And what's going to happen here, so I've got a slot milled. It's a 1/4 inch slot. This is a quarter inch bolt. So it's going to slide back and forth in that slot. And it's got kind of a T-nut looking little fella that drops in there. All right, and that sits just below the surface. And what's going to happen is, let me get this clamp off of here. This is going to go into this clamp, down into that little T-nut goodie. And this is going to be for adjustment, and it's going to allow it to tip. And when we tighten down, we're not only adjusting the angle of the bar, we're also pinching the bar and letting it self-align in this direction here. Let me tighten that up just a little bit more, and I'll show you what I'm talking about. Okay, there we are, and we're still capable of motion. So there it is there. The bar is going to slip through there. When we tighten that bolt, it's going to pin it down to this deck. And there's our little slider there. So that's our range of motion for setting the angle of the bar. And when we tighten down right now, and we slip right in there. Okay. So whatever angle we end up at, if we're here like this and we're swinging the bar back and forth like this, and we get to a happy angle, we're just going to tighten up here. And that whole assembly is basically as one. It can't turn, and it's rigid. All right, so that's my version of a taper attachment. Okay, that takes care of the adjustable end down here. As you can see, that's all bolted together and as one. Now, turn you a little bit over here. Now, what are you going to do down here? This is going to be going on this way. And here's our other bar. This is the headstock end down here. And all I'm going to have on this one, this one's probably going to end up being shorter. I haven't finished this one. I'm probably just going to have a series of holes that this will just thread straight down into. I haven't even cut off the end yet. That's still just a raw, nasty thing. So I'm thinking just a series of holes on 1-inch centers all the way down to allow me some adjustability, and call it a day on that one. Now, knowing how critical linear bearings are to alignment, a few things have to happen. These two planes here, as you can see, they're not surface ground or even machined out here. It's just the raw flat stock here. If these two are tipped this way, and maybe the other one's tipped down, or this way, or anything like that, and this isn't on a constant elevation, it's going to give you a problem. It might work good down at one end and not the other, but your linear bearings are going to go into a bind at some point, and we want it very free floating and with no binding on the way through. So these are going to have to end up being surface ground. The height of this bar is going to have to be checked on the machine. After we've established that the two clamp blocks are very flat and very parallel and very even with the machine, and very equal to each other, then we have to establish these little clamp blocks and make sure that when we drop them on our clamping blocks, or our main base blocks, that they're at the same elevation, even if we have to surface grind one to dial it in. But we can come in with an indicator, check the top of our bar here, check the top of our bar here, and over this distance I wouldn't want to see, I don't know, maybe a thou over this whole length. We'll just need to get it as close as we possibly can on your elevation. And when this bar over here, switches and changes, it can't change elevation. So this one definitely has to run dead flat in relationship to the other one. They both need to be flat. So anyways, that's the makings of a taper attachment. Let me get a little farther into this. I'm going to get my holes drilled in that other one, and I'm going to do a mock-up install. I'm going to save the surface grinding for last, but I need to get a carriage made here for the center. And what I'm probably going to do here is I'm going to use both bearings, probably make like a yoke that catches both bearings with a single attachment point in the center off to the carriage from there. All right, so these will be, they're going to hold themselves in a line, which will actually help strengthen the bar. The farther apart you get these, and if this is in a rigid carrier, that'll help keep the bar straight. You can see there is deflection. I can push very hard right here, and you can probably see that on camera that there is deflection. But the farther apart you get these bearings, the better they're going to run. Put them up tight like that, it's no good. So a couple inches apart with a yoke, single pin with attachment to the carriage. All right. Let me get that other clamping block tapped, and we'll do a quick mock-up on the machine so we can have a look at it. Okay, I think we're ready for our first mock-up. We're going to start with this clamp that goes on the bed, and I went ahead and drilled and tapped a series of holes, and this is the headstock end, obviously, and that's just fits down over the bed just like that. And remember, we put that little relief in right where my thumb is there, just so it fits on this outside corner. This is a very sharp outside corner right here, and you don't ever want to roll that over or anything. And I'm trying to work around the camera here, but we're just gonna do a little clamp there, clamp there, and make sure that's seated against this surface on that little milled section. And then sneak in here with a little tiny Allen wrench. and tighten those up. And that is solid. Okay, nice. Now, we have to approximate our length of everything. This fellow's going to either go, they gave us a series of holes. You know, so you'd have to move that bar down so it misses that. I like it there though. Okay. And then this slides in and out here until we tighten that down. So that's going to give us our movement there until we pinch. When we pinch here, it's going to clamp down on the shaft and hold that alignment or that angle rigid. So they're essentially self-aligning. Now, I need to get my other one in over here, but do my length properly. Let me move the camera. I'll bring you right back. Okay, welcome to the tailstock end. Again with the bar with the clamp that clamps to the bed. This is the one with the slot in it with a big giant hole in the bottom. We've got a little flat bar that's going to actually clamp in on the bed. I'm just going to loosely put this in here. So I could probably still move it around a little bit. And now we're going to grab our bar. And what's nice about this is I can move in and out here to do my alignments. So, you know, by moving the two main pieces up and down the bed, the two main brackets up and down the bed, I can make this bar as long or as short as I want. So that's actually pretty cool. And we're going to take our little nut that we made, go down in that recess. Okay, I'm back. I had to go get a tad longer bolt. I want to make sure I catch at least the first couple of threads in there or beyond. So we're going to put our little T-nut or whatever you want to call that down in there. Okay. And our other bolt is still kind of loose back there. And we've got adjustability. Okay, that's nice. Loosen that up a little bit. There we go. So we can adjust way out to there, way into there. So pretty cool. And I was thinking we'd be about parallel. Right about there. So your range of motion is going to be from here to here. I'm thinking I might go back in that other block over on the headstock end. Those holes are on 1-inch centers. I might go through and put them on 1/2-inch centers to give me some more adjustability. And but see, now our rod is spinning, so it's let's just put it at a skew here. So it's self-aligning. This block turns, and see now my rod is free to float. But now when I tighten here, that's going to pinch the rod and maintain that angle, and that rod ain't turning. And now we can tighten up our headstock end. And that's going to help maintain the bar being rigid over the full length just by clamping them here and pinning that position and not forcing them into any type of bind. Let's look here in the center. This is where we would be attaching to our compound. So what kind of deflection we're getting. Actually, I'm going to go get an indicator and see. I'm pushing pretty hard with my thumb and I can see it deflecting. And I don't have any way to measure cutting forces when it's cutting, but you know, on your final cut, you're just making a little light skim cut, so your cutting pressures go down and down and down. So you're going to start out with inaccurate cuts when you're doing your heavy cuts, but then when you come back for your final and your light cut, your cutting pressures are very low. Let me throw an indicator on that just for grins and see what kind of movement we get. Okay, we are pretty much dead center of the bar, and I'm going to push with my thumb just as hard as I was pushing before. I'm pushing pretty hard, I'm getting about 4 thousandths of flex out here in the center. And what I'm hoping is when I build that carriage with these 2 linear bearings and a yoke, that's going to probably take some of that away, because these will actually stiffen the shaft because they're riding so far apart, and that yoke helps stiffen that center part where these are traveling. So I'm hoping to get some more of that away. Okay, we're back on our on our rod here, and I was going to show you. We were talking earlier about wow, look at those wipers push the dirt and stuff away. Cool. We were talking about the linear bearing spacing. Now, if I'm going to try to do this. I don't have a strain gauge or anything like that. I'm going to try to push right here with both hands and push in. See, I can get about 5 thousandths, but right in the center. So if we've got our bearings very close, that's the kind of forces you can create on this shaft to cause it to flex. But if we spread them out, keep in mind, my carriage is my limiting factor anyways. So these bearings could be this far apart, because this carriage right here is going to bump into this stop, and you know, then that keeps this bearing clear of my my clamp over here, and same thing over here. So these bearings can be spaced this far apart. So if I was to push with both hands again out here, I'm only getting 2 thousandths. So between a concentrated load bearing and a spread out load bearing, it's night and day. So the farther apart I can get these linear bearings, the better off, and the less shaft flexing I'm going to get. And I've discovered this from using the linear bearings for we use them for spray gun reciprocators. That's what automatically sprays things, and deflection is a factor in those too. So we're going to make a yoke to go across these 2 bearings with a single point connection into the carriage. All right. I'm going to take you around for a brief overview, and then we're going to wrap this. Thought I'd give you an overview of the whole thing and do kind of a walk around, let you see what all it's looking like here. All right, guys. I'll keep you guys updated as this progresses and let you know if I can make it work. I'm saving all the surface grinding for last. I am aware that this bar needs to be very parallel or on the same plane as the bed, both here and at the headstock. So as this thing travels down, these linear bearings don't go into a bind. They might start out fine here, but as they travel down, if it's going downhill or uphill, it could very well go into a bind. So I'm very, very aware that this top plane right here is very critical. All right, guys, thanks for watching.